Hi everyone. So this is our last big topic of the year, exponent rules. Today's lesson is hopefully for most of you a review of exponent rules that you learned in grade 9 and grade 10, but they're also really important for next year as well. And then after this we'll be moving on to new things. So this week our next lesson we're going to learn how to solve exponential equation. And then next week we're going to learn the meaning of fractional exponents, which are really important for next year as well. All right, so our learning goal is to learn to evaluate numeric exponential expressions involving exponents. And the exponent laws we're using are, back in grade 9, when you multiply powers with the same base, you keep the base the same and add the exponents. When you divide powers with the same base, you keep the base and subtract the exponents. If you have a base to a negative exponent, it's the same thing as having 1 over that same base to the positive exponent. If you have a negative exponent in the denominator, it's the same as moving it up to the numerator and having the exponent be positive. If you have a fraction to a negative exponent, this is a really important rule to use and use quite often. If you flip the base, the exponent becomes positive. If you have a fraction to an exponent, it's the same as having the numerator to that exponent divided by the denominator to that same exponent. If you have a product, so two numbers multiplying together to the same power, it's like having one of those to that power times the other one to that same power. And then this one, another important one, when you have a power to another exponent, you keep the base the same again and you multiply the exponents together. So these were the three you learned in grade 9, and I would say you probably learned that one in grade 9 as well. And then you added on these ones in grade 10. And now we're just going to practice using them. So notice what the instructions say for this question. Evaluate, so find the exact value. So we don't want any decimals in our answers, even if they're exact decimals. We want to state our answer as fractions by applying appropriate exponent laws to first simplify. So you can't just go straight to the final answer. You have to show that you've used an exponent rule or an exponent law first to simplify it as much as possible. The very last step, you could evaluate, and that's where you might use your calculator in the end if you need to. Okay, but you want to simplify by using the exponent rules. So if you look at the first question here, 10 cubed divided by 10 to the 6th, you notice that, if I look back here, we're dividing powers that have the same base. So the rule is, so we're not doing this on our calculator, we're keeping the base 10 the same and subtracting the exponents. 3 minus 6 gives me -3. So there's one rule I've used, okay? But now I can use this rule. When I have a number to a negative exponent, it's the same as 1 over that number to the positive exponent. So now I've used two rules. And now I can evaluate 10 cubed. I know that's 1,000. If I had to use my calculator to figure out 10 cubed, that's when I would use my calculator. Okay? 5 to the -2. All right, so that's this one again. A base to a negative exponent is the same as 1 over that base to the positive exponent. And then now is where if I needed to, I could use my calculator, but most people would know that 5 times 5 is 25, so the answer is 1/25. So brackets the -4, that means the base is -4 to the exponent -2. So similar to this question, it's going to be 1 over, and I do need to show the brackets, -4 to the +2, showing that the base is -4, not just 4, which is 1 over, so -4 times -4 is +16. So my answer would be 1/16. All right, and then notice how the next question is negative without brackets, 4 to the -2. So that's going to be different. The exponent of negative 2 only corresponds to the 4. The negative's out front, okay? So I can think of it as negative 1 in the numerator over, so 4 to the positive 2. So I keep my negative 1 in the numerator, and 4 to the positive 2 is 16th, so negative 1/16. So you can see that how our answers are different. So it matters whether there's brackets or not brackets. Okay, so in this case the base is negative 4, in this case the base is just 4 only. 2/3 to the negative 2. So I have a fraction to a negative exponent. Fraction to a negative exponent. The rule is you flip the base and the exponent becomes positive. 3/2 to the positive 2. So there's one rule. Now I can use the rule where I put, if I have a quotient to an exponent, it's the same as having the numerator to that exponent over the denominator to that exponent. So 3 squared over 2 squared, or 9 over 4. Oops. 9 over 4. All right, F, 2 cubed divided by 2 to the negative 4. So that, as soon as you see the same base, hopefully you think about, okay, I've got the same base. It's got to be one of my same base rules. So am I multiplying? No. Am I dividing? Yes. So I'm dividing powers with the same base. So the rule is to keep the base 2 and subtract the exponents. 3 subtract negative 4. When you subtract a negative, you add. So you'd end up getting 2 to the positive 7. And then if you need a calculator for that, go ahead, 2 to the power of 7. So if you don't remember what your power button is, it could be y to the x. It could be an up arrow. It could be x to the y. I think those are the usual ones. So 2, mine's an arrow, to the power of 7, 128. So use your exponent rules before you go to your calculator, okay? To show that you know them and you're using them to simplify. Okay, so the next one, 3 to the 5th times 3 to the negative 2 divided by 3 to the negative 3 squared. So we've got the same base all over the place here. So in the numerator, I'm multiplying powers with the same base. So I have keep the base the same and add the exponents. 5 plus negative 2 is 3. In the denominator, I have a power to another exponent. A power to another exponent. So that's where you keep the base and multiply the exponents. So I keep the base 3 and multiply the exponents. Now, I still have the same base in the numerator and the denominator. So now I'm dividing powers with the same base. So I can keep the base the same and subtract the exponents. Subtracting a negative means you're adding. So once you get it to 3 to the 9th, 19,683, you could go to your calculator. So for this question, you get 1, 2, 3 marks. Okay, and if you just did it on your calculator and got 19,683, you'd only get 1 out of 3. You have to show that you've used the exponent rules. Okay, again, in the numerator, we're multiplying powers with the same base, so keep the base and add the exponents. Negative 4 plus 6 is 2. Now we've got division of powers with the same base, so we're going to keep the base and subtract the exponents. 2 minus 3 is negative 1. Then we're going to use our negative exponent rule, so it's going to be 1 over 5 to the positive 1. I don't need to show the positive 1, so my answer would be 1/5. 3/5 to the negative 3, so we've got a fraction to a negative exponent, so we know to flip the base and make the exponent positive. Then we can use the rule where we have a fraction to an exponent. It's the numerator to that exponent over the denominator to that exponent. And then if we need to use our calculator, 5 to the power of 3 should be 125, and 3 to the power of 3 should be 27. 2 to the negative 1 plus 3 to the negative 1. So even if these were both 2's, there's no rule for adding powers with the same base, okay? So I would have to treat them separately anyways, but I have a negative exponent in each case, so I could rewrite 2 to the negative 1 as 1 over 2 to the positive 1, which is a half, plus 3 to the negative 1 I can rewrite as 1 over 3 to the positive 1. And now it just becomes an adding fractions question. So we have to remember that to add fractions, you need a common denominator. And the common denominator of 2 and 3 is 6. I have to adjust the numerator, so 2 times 3, 1 times 3. 3 times 2, 1 times 2. So 3, 6 plus 2 more 6 is 5, 6. Then you can see that these questions are related because we just found out what 2 to the negative 1 plus 3 to the negative 1 was, which was 5, 6. So we could write this as 5, 6 to the negative 1. And then we have a fraction to a negative exponent, and the rule is flip the fraction to the positive exponent, and the exponent of 1 just keeps it the same. All right. Similar type of question to what J was, but with fractions as our base. So 2/3 to the negative 1 is the same as 3/2 to the positive 1. 2/5 to the negative 1 is the same as 5/2 to the positive 1. So that's just going to be 3/2 plus 5/2. So we get lucky that we already have a common denominator. So we would end up with 8/2, which happens to be 4. M, 1/4 to the negative 3, so we have a fraction to a negative exponent, so we're going to flip our fraction. 1/4 flipped is just 4, because you don't need 4 over 1, because 4 over 1 is 4, and 4 cubed is 64. 5 squared minus 1/3 to the negative 2, so 5 squared is 25. Minus, so we have a fraction to a negative exponent, so we can flip the base. If we flip 1/3, we get 3 over 1, which is just 3 to the positive 2. 3 squared is 9. 25 minus 9 is 16. Okay, in O, we can see we've got this common base throughout. So there's probably going to be some rules we can use. In the numerator, we've got power to an exponent times another power to an exponent, so we're going to do those power to exponent first. So keep the base, multiply the exponents. So keep the base, multiply the exponents. Then in the top now, we're multiplying powers with the same base. So when you multiply powers with the same base, you keep the base and add the exponents. So 10 plus negative 6 is 4. And then it turns into dividing powers with the same base. So we keep the base and subtract the exponents. 4 minus 2 is 2. And then finally we evaluate, so we would get 3 squared is 9. So again, this question, there'd be 1 mark for doing that. 2, 3, 4 marks. Okay, and 3 of them are using exponent rules, showing that you know the exponent rules. Just at the very end, you're finding out what 3 squared is. P, so you can see the negative 3 is the same base, so we're dividing powers with the same base, so we're going to keep that same base in brackets negative 3. and subtract the exponents. Careful when you subtract a negative. So -7 minus -9 is +2. -3 times -3 is +9. Q, I'm going to put a little star beside. A lot of people, their first inclination is to keep the base and add the exponents and get 2 to the -6, but that's not right because we're not multiplying these, we're adding them. So when you're adding them, you have to, there's no rule for adding powers with the same base. You just have to take each one individually. So 2 to the -1 using our negative exponent rule is 1 over 2 to the +1, which is just a half. 2 to the -2 using the negative exponent rule is going to be 1 over 2 to the +2. And 2 to the -3 is going to be 1 over 2 to the +3. So that's going to be a half plus a quarter plus an eighth. So we're adding 3 fractions. We need a common denominator, which is going to be 8. So here we had to multiply the bottom by 2, so we have to multiply the top by 2. Here we had to multiply the bottom by 4, so we have to multiply the top by 4. So now they're all in eighths. 4 eighths plus 2 more eighths is 6, plus 1 more is 7 eighths. Okay? So be careful on the adding questions. And this one kind of something we learned how to do in the chapter on rational expressions, also way at the beginning of the year, where we're going to have the 4-layer fractions that we're going to eventually get to a 2-layer fraction. So again, we're adding in the numerator and the denominator, so there's no rule for adding powers. Okay? So we have to take them each individually. So 4 to the -2 is 1 over 4 squared, which is 1/16, plus 3 to the -1 is 1 over 3, so 1/3. Over 3 to the -2 is going to be 1 over 3 squared, so that's 1 over 9, plus 2 to the -3 is 1 over 2 cubed, which is 1 over 8. So 2 to the -3 is 1 over 2 cubed, and that's my 1 over 8. So now I've got this 4-layer fraction, and that's never simplified. I have to get to a 2-layer fraction in order to have it simplified. So first I'm just going to look in the numerator for a common denominator. So a common denominator between 16 and 3, I have to go all the way to 16 times 3, or 48, to get a common denominator that works. So that's 16 I had to multiply by 3, have to multiply the top by 3. Here I had to multiply by 16, so I have to multiply the top by 16. Similar in the denominator, I need to add those fractions, so I'm going to have to come up with a common denominator of 9 and 8, and it turns out that's not easy either. 72 is the lowest. So 9 times 8, 1 times 8, 8 times 9, 1 times 9. So 16 and 3 is 19. 48ths divided by 17 72s. So now we're dividing fractions. So we're going to multiply by the reciprocal, which is going to give us 19 times 72, 1,368 over 48 times 17. So looking at these, 19 and 17 don't have any factors in common, but 72 and 48 at least have 12 in common. I think they have 24 in common actually, so we can divide top and bottom by 24, I believe. So 1368 divided by 24 is 57. And 816 divided by 24 is 34. So there we went from a 4-layer fraction to a 2-layer fraction in lowest terms, and that's our final answer. So that's a recap of all the exponent rules you learned in grade 9 and grade 10. And our success criteria is to use the appropriate exponent rules to simplify first and then evaluate an exponential expression. So if you haven't used exponent rules within your answer and you've just gone straight to your calculator, then you aren't doing it properly. Okay? You have to show your knowledge of the exponent rules. They're really important in grade 12 when you learn logarithms. All right.